Welcome to Mathematics Educators Workshop at Home. Today we are looking at the concept of trigonometry with the grade 11. And our famous question at Mathematics Educators Workshop at Home is, how well can we teach? So the question of the day is, how well can we teach trigonometry to the grade 11s? Now let us go and see how well we can teach the concept. Now, we are going to look at trigonometry of grade 11. The first thing that we're going to do is we're going to try and use the learner's prior knowledge as a foundation of the grade 11 concept. We do not just go straight to formulas that are used in grade 11 trigonometry. We go back to prior knowledge and use it as a foundation of our lesson today. The first thing we're going to look at is a revision of what an angle is. These learners, they were introduced to concepts of angles from as far as grade 8. Now we say an angle, it is formed by two rays that shares a common point. The rays, they are usually called the arms of the angle. One of my old textbook that I was using, it said they are usually called the arms or the legs of the angle. And the common starting point of the angle, it is called the vertex of the angle. Now, let us look at the example that I just put here. There is an angle formed here between two rays. Now, this angle is made by these two rays, the first one here and the second one there. You will notice something here on the rays that I wrote radius, and I will talk about that just now. But let's talk about this terminal arm, the ray that opened up to form the angle. This arm here, it is called the terminal arm or the terminal leg. That is the arm that opened up to form the angle. Now, why am I calling this terminal arms the radius? Now we say, when this angle moves in anti-clockwise as it is moving and come back from the other arm where it opened from, it would have completed a circle. That angle, it is called a revolution. So when this terminal arm comes back and sit where it came from, it completes a revolution, a 360 degrees. And in that revolution, we say that that terminal arm would have completed a circle. Now, what is the radius? We know from grade 8 definition that the radius is the distance from the center to the circumference of the circle. So that would have completed the radius, and that arm of the terminal arm is then referred to as the radius. Now, let us look at other important things that we must talk about before the actual concept. The concept of the angle being negative or positive. We say angles that moves in anti-clockwise direction, they are said to be positive angles. So I've got the horizontal line that is sitting here, and therefore there is an angle that opened up by that terminal arm. It is moving in anti-clockwise direction. I'm going to give it the name and call it theta. So we say this theta, it is positive. Why? Because it is moving in anti-clockwise direction. Now, I'm just going to make 3 examples. Let us look at the angle 60 degrees, 110 degrees, 200 degrees, and 310 degrees. All these angles are positive. So how do they move? I'm just going to represent them here. I draw a Cartesian plane. Now, let me just use a different color so that this will be able to will be visible. Now I'm saying the other arm lies here on the x-axis and the terminal arm opened there, forming the 60-degree angle. Now this angle here, it goes in anti-clockwise direction. The other angle that we have is 110 degrees. So 110 degrees will be found here because where it is starting, it is at 0 degrees. That is 90 degrees. That is 180 degrees. And this is 270 degrees. And when it comes back here, it completes the revolution at 360 degrees. So this angle that is completed here, it is 110 degrees. Now, this angle is moving in anti-clockwise direction. The other one is at 200 degrees. Now, 200 degrees will be found in the third quadrant. So this is 200 degrees. And 310 will be found in the fourth quadrant. So this is 310 degrees. All these angles, they are positive. So that is where their terminal arms lie. Let us look at the negative angle. If an angle open from the horizontal surface and open in clockwise direction, that angle is said to be a negative angle. I'm going to give it the name theta. So this angle is negative. Let's look at some examples. Negative 30 degrees, negative 110 degrees, negative 220 degrees, negative 315 degrees. So I'm just going to represent them quickly here on the Cartesian plane, just so that this concept of negative angles can also be clear. So negative 30 degrees. The other arm of the angle lies on the x-axis, and therefore negative 30, the angle opens in this direction, and that is negative 30 degrees. So that means this is 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. So this is a Cartesian plane with angles that are moving in a clockwise direction. The other angle that I have is negative 110 degrees. This angle, it is found in the third quadrant. So this is negative 110 degrees. Now, the other angle we have is negative 220. So negative 220, the angle moves in clockwise direction. So this is negative 220 degrees. And the last one there, we have an angle that is found in the fourth quadrant, which is negative 315 degrees. So these are angles that are moving in a clockwise direction, and these are angles that are moving in anti-clockwise direction. Very important for the learners to understand this concept. Now, the other important thing that the learners learned in grade 10, it is the concept of the angle at standard position. The angle at standard position, this is when an angle is drawn with one arm of the angle lying parallel to the x-axis and its vertex at the origin of the Cartesian plane. Therefore, that angle, it is drawn at standard position. So I used an example of positive angles here that are drawn at standard position. Let us look at the first diagram. So the angle drawn at standard position here, the first terminal, the other arm lies here on the x-axis, and the terminal arm is up there. Now, we need to calculate the length of the radius, the length of the terminal arm, so that we can be able to talk about trigonometric ratios. So if I have the length of the terminal arm, I'll be able to relate the trigonometric ratios as these learners, they've learned this in grade 10. So we know we have to construct a perpendicular line here and complete a right angle triangle. Now, if this is a right angle triangle, therefore OP is the hypotenuse. So we say OP squared is equals to x squared plus y squared. So we say the length from here to there is x, and the length from here to there is y. But these values, they've got the coordinates there by the point P. So this is r squared is equals to x is 2 squared plus 3 squared. Now this is 2 squared is 4 and 3 squared is 9, and the final answer is 13. Therefore, r is equals to the square root of 13. Now remember, I just took the square root both sides, but what does this r stand for? This r represents the length of OP. So it's not the coordinate, and the length, it is not negative. It is forever positive. We can only use negatives in order to indicate direction, but that is positive. So the length of OP is the square root of 13. Now, again, I want us to look at the definitions of trigonometric ratios as they did in grade 10. They said the sine of theta, it is given by the side length of the length of the side opposite to the angle theta divided by the hypotenuse. Cos theta is equals to the length of the side adjacent to the angle theta over hypotenuse. And the tan theta, it is equals to the length of the side opposite to the angle divided by the length of the side adjacent to the angle. So these are the basic definitions of trigonometric ratios that these learners did in grade 10. Now, I just want to use both. If you look at the first diagram, I'm representing this information numerically. The diagram on the far right, it is represented algebraically with variables. Now let's go and complete the concept, the diagram there with variables. So again, in this quadrant, I simply complete a right angle triangle here, and I know that this distance is x and this distance is y. So let's go back to the first diagram. In this first diagram, we have the radius is square root of 13. I'm going to apply these trigonometric ratios definitions to express these trigonometric ratios with the values here. So this will be sine theta is equals to y over root 13, and y is 3. That is 3 over root 13. And cos theta is equals to 2 over root 13. And the last one is tan theta is equals to 3 over 2. Now, I believe they remember this. They did this work in grade 10 extensively, so they wrote the exam with this work. Now we say the ratio of sine theta, it says the length of the side opposite to theta over r, and that length in this case is y. So this will be y over r, and this will be x over r, and the last one will be y over x. So this is the basic concept of trigonometry that the learners learned in grade 10. Now, let's go and look at the Cartesian plane. Very important. We are going to discuss the nature of the values in each quadrant. Now, in this quadrant, in quadrant 1, we see the value of x and y, they are both positive. Why? Because the values of x here, they are positive, and the values of y here, they are positive. So both, they are positive. When we go to the second quadrant, the values of y, they are positive, but the values of x, they are negative. When you look at the third quadrant, the value of x, they are negative, and the values of y, they are negative. So both they are negative. And when you look at the quadrant 4, the values of y they are negative, and the values of x they are positive. Now, just going back to what we just did, we talked about trigonometric ratios. We said the trigonometric ratio sine theta is equals to y over r, and cos theta is equals to x over r, and tan theta is equals to y over x. So if you look at these trigonometric ratios, in the first quadrant, x and y, they are all positive. Therefore, all the trigonometric ratios will be positive in here. All the trig ratios, they are positive in this quadrant. But when we go to the second quadrant, which ratio has to do with x is the cosine and the tangent. But the value of x is negative in this quadrant. Therefore, only sine theta is positive. The rest, they are negative. Tan theta is negative, and cos theta is negative. Why? Because it takes x, and the value of x is negative here. Now, when you consider the third quadrant, both x and y, they are negative. Therefore, if you check from this trigonometric ratio, y is negative, therefore sine theta will be negative. If you check this trig ratio of cosine, x is negative, therefore this will be cos theta is also a negative ratio. But when you look at the tangent, it takes both x and y. So in other words, we'll be having negative y value and negative x value. So this divided by that gives us a positive value. So the tangent is positive in this quadrant. Now let us go and look at the quadrant number 4. In quadrant number 4, x is positive, but y is negative. The trigonometric ratios that takes y is the tangent and the sine. Therefore, they will be negative in this quadrant. Only cos theta will be positive. Tan theta is negative, and sine theta is negative. So this is why you hear people talking about the cast diagram, CAST. Now they're talking about this diagram of quadrant. The cast start from, this is C, cos is positive in the fourth quadrant. Now we've got A stand for all positive in the first quadrant, and sine is positive in the second quadrant, and the tangent is positive in the third quadrant. That is where the concept of the cast diagram comes from. So now there is a planned baseline task which it aims to see the learner's understanding of what has just been discussed here in terms of the negativity and positivity, or the nature of trigonometric ratios in specific quadrants. So allow the learners to complete this task. So let's see the task. Is in which quadrant does the terminal arm of the angle lie? If sine alpha is positive and cos alpha is negative. 1, we know that if the terminal arm lies in the first quadrant, all of them, they are positive. But this one, it says sine is positive and cos is negative. In which quadrant is sine positive and cos negative? That is the second quadrant. The second one says sec x is negative and tan x is positive. So sec, it is the reciprocal of cosine. In which quadrant is sec and cosine negative? They are negative in second quadrant and the third quadrant. But it further says tan is positive. So tan is positive in the third quadrant and the first quadrant. Therefore, this should be the third quadrant. Question number 3. Cosec beta is positive and cot beta is negative. Cosec beta is a reciprocal of sine. In which quadrant is sine positive? In the first quadrant. Now, it says cot is negative. Obviously, cot is negative in that quadrant. So, that is the second quadrant. Now, you allow this learner to complete this, and therefore you give them 4 minutes, 4 questions, 4 minutes, they should be done. Now, let me show my response. So, these are the answers. The first one is in the second quadrant. The second one is in the third quadrant. The third one is in the second quadrant. And the fourth one is in the second quadrant. If you check it carefully, the questions are the same. It's just the difference of the angle. Sure. So that is basically what is being asked there. Now let's move on with that concept. The next thing that we're going to deal with is dealing with trigonometric ratios and the terminal arms of the angle in different quadrants. Now, we say if the terminal arm lies in the first quadrant, all the trigonometric ratios are positive. We just discussed that. So, theta lies in the first quadrant. Therefore, all the values, they are positive in here. All trigonometric ratios, they are positive. And therefore, if you look at the terminal arm that lies in the second quadrant, in this quadrant we said only sine is positive, right? Only sine is positive and the rest, they are negative. The terminal arm that lies in the third quadrant, we say only tan is positive, the rest, they are negative. And the last one, it is in the fourth quadrant, and we say in this quadrant, only cos is positive. Like I just gave a summary earlier that this is referred as a cast diagram. Now, with all the information that we discussed about the cast diagram, we should be able to complete the following exercise. This exercise, it is meant to strengthen the learner's understanding of the nature of trigonometric ratios in various quadrants. So let's look at that. Example number 1. The question says, if the terminal arm of theta in standard position, it passes through the given points below. Calculate the values of, so the point that is given there is 3 and 4. So let me put that angle at standard position. So this point, it is in the first quadrant, is 3 and 4. So the terminal arm of this angle goes through that point, and we've got our angle theta here. So in order to solve this, you simply complete your right angle triangle here and determine the length of r. So let me use a different color so that is visible. So I simply say r squared is equals to x squared plus y squared. Now what is r squared? Is our radius there, or the length of the terminal arm. So this is going to be 3 squared plus 4 squared. Now 3 squared is 9, 4 squared is 16, and that gives us 25. Therefore, r is equals to 5. So r is equals to 5. Now we can be able to solve all those questions. Now, solution. Question 1. Sine theta. Sine theta, it is equals to y over r. That is 4 over 5. Now, question 2 says cosec theta. Cosec theta. Cosec theta, it is the reciprocal of sine theta. Therefore, it is equals to 1 over sine theta. Therefore, 1 over 4 over 5. This is equals to 5 over 4. And the last one, which is question 3, is tan theta is equals to y over x, so that will be 4 over 3. And we have answered the questions. Now, I'm going to remove this solutions so we can take 2 more questions, because if you check the instruction, it said points. The terminal arm is going through the point, not one point. So let's look at that. So I'm just going to remove the solutions here so that I can bring up the new questions, set of questions. So let us look at that. We are saying the second question says, example number 2, the point is negative root 3 and 1. In which quadrant do we find this point? This point is found in quadrant number 2. The value of x is negative, but the value of y is positive. So you simply draw a set of x's and you put the angle there. So the angle is in the second quadrant. For the point here, the point is negative square root of 3 and 1. So you drop a perpendicular to complete a right angle triangle. Now, one more thing that we need to clarify to the learners so that they don't make mistakes. So the angle, it is a positive angle that moves in anti-clockwise direction. So our angle is this side. But remember that trigonometric ratios only works with acute angle. So this angle is the one that opens up, and this angle is more than 90 degrees. But there is this acute angle here that gives the same position of the terminal arm as that bigger angle there. So this is the angle that we are going to work with. So this becomes, we have our point there. We need to calculate the length of r. So we simply say r squared is equals to x squared plus y squared. And x squared is negative square root of 13 squared plus 1 squared. Now, negative square root of, sorry, it's not 13 but 3. Negative square root of 3 squared will give us 9 plus square root of 1 squared is 1. So this gives us 10. Therefore, r is equal to the square root of 10. So this is the square root of 10. Now, we can now be able to solve this question. It says cot theta. So cot theta is a reciprocal of tan theta. So tan theta says y over x. Therefore, cot theta, it is x over y. So this is going to be, the ratio is negative square root of 3 over 1, which is negative square root of 3. The last question is cos theta. Cos theta, it is x over r. So x is negative square root of 3 over the square root of 10. So in other words, this is the same as negative square root of 3 over 10. So this is the ratio of cos theta. Now, let's look at the next question. Now, I'm just going to remove all this work. The next question, they say, if sine x is equal to negative 3 over 5, if sine x is equal to negative 3 over 5, and the angle x is the angle between 270 degrees and 0 degrees, is the angle is less than 270 degrees but greater than 0 degrees. So I'm saying if sine x is equal to negative 3 over 5 and x is less than 270 but bigger than 0 degrees, determine the values of this expression. So let's see. I'm just going to represent those angles. This is 0 degrees, that is 90 degrees, that is 180 degrees, and this is 270 degrees. They say X is the angle that is between 0 degrees and 270. It's smaller than 270 but bigger than 0 degrees. So this angle, X could be in the first quadrant or could be in the second quadrant. Furthermore, they gave us this ratio. They say sine X is equals to -3/5. What does the ratio of sine say? We say it is y/r. So that means the value of y is negative. In which quadrant is the value of y negative? Between the quadrant 1, 2, and 3. It's negative in the third quadrant. So this angle lies in the third quadrant. So this is the angle. And the acute angle we're going to focus on is this. So we simply complete our right angle triangle like that. And therefore, the coordinate of this point, we don't know the value of x, but we know the value of y is -3. We also know the radius is 5. We just need to use Pythagoras to calculate the length or the value of x. So this is x squared plus y squared is equals to r squared. So x squared plus y squared, y is how much? Is -3 squared, and r is equals to 5 squared. So this gives us x squared is equals to 5 squared is 25, -3 squared is 9. So that would be 25 minus 9 is 16. Therefore, x is equals to ±4. Now, we consider the fact that this angle, the terminal arm lies in the third quadrant and the value of x has to be negative. So, x here is -4. Now, if x is -4, then we can now be able to answer what is given to us. So let's go and consider the question that is given here at the bottom. They say we must determine the value of this expression. So we simply write the first value there is sine x. Therefore, sine x is equals to -3/5. It was given plus cos x. Cos x is -4/5. We just calculated the value of x is -4 all over sec x. Sec x is the reciprocal of cos, so it's going to be r/x, which will be 5/-4 plus cosec x. Cosec x is the reciprocal of sine, so sine is y/r, therefore this will be r/y, which is -3, and therefore we simply get the answer. Now, in this question, there is no need for you to show your fraction skills. You can simply use your calculator if you've got a challenge, get the answer. But obviously, if you don't have a problem, you can just add them up. So the LCD is 5 from the numerator. You simply say 5. That is -3, -4 is -7. So that means that is -7 over, it is -7/5 divided by this at the bottom here. The LCD is not the same. We've got -4 and 3. So the LCD of that is, so I'll give that negative there so that I don't mess up the LCD. The LCD will be 12. So 4 into 3 is 12 times, 4 into 12 is 3, and times 5 is -15 plus 3 into 12 is 4, and 4 times 5 is 20. So this is just going to be -7/5 multiplied by, so this is -35, so it's going to be 12/35. So it is going to be a positive answer, and then you simply find the answer of that, which is 7/5 times 12 over 35, and the answer is 12 over 25. And that is the answer. The last question, they say 2 sine x, so is 2 sine x. Sine x is negative 3 over 5 plus 3 cos x. Cos x is negative 4 over 5 minus 3 cosec x. Cosec x is negative 5 over 3. And then you simply get the answer of that. So we're saying it's 2 times negative 3 over 5 plus 3 times negative 4 over 5 minus 3 times negative 5 over 3. And the answer is 7 over 5. So that is the answer. Now, once you are done with a set of questions like this, it is very crucial to test learners' understanding. So I developed the same structure, the same kinds of questions with different problem statements. So this is what the learners